Today we will discuss second t-test. Previously we have seen a test which is based on single sample. So that is test for population mean H naught mu equal to mu naught. Now we will discuss the second test, and this is test based on two populations. Suppose there are two populations X and Y. So X is one population, Y is another population, and the two samples were taken from these two populations. So our point of interest in this case is we have to test the equality of means of two populations. So that means whether the mean of the first population is same as mean of the second population. So therefore in this case our H naught becomes mu1 equal to mu2. So this test is also called as unpaired t-test. So why this is called as unpaired t-test? Because the sample sizes are not equal. So that means the sample size of one sample supposed to be X, which is not same as the sample size of the second group. So the second sample. So these two sample sizes are not same. So therefore we have to pool their variances, and this is also called as independent t-test. So what are the assumptions in this case? See, the assumptions in this case are the parent population is normal. So that is the primary assumption for all the t-tests. So the two samples are random and they must be independent. The population variances sigma 1 square and sigma 2 square both are unknown, but the population variances, even though they are unknown, they are supposed to be equal. So that means sigma 1 square equal to sigma 2 square equal to sigma 1 square. So what is sigma 1 square? Sigma 1 square is the variance of the first population. Sigma 2 square is the variance of the second population. And again, one more important thing is the sample sizes are small and they are not equal. And what we have to test, see, any test procedure consists of 4 steps. And what are these 4 steps? The first step is related with the hypothesis, setup of the hypothesis. The second test step is related with the test statistic. The first is hypothesis, build up the hypothesis. The second is find out what would be your test statistic for this test. The third one is go and find out the critical region, and the next step is related with, so this is the conclusion part. So in this way we can we are studying all the tests based on the testing of hypothesis. Now, so see, what is my hypothesis in this case? My hypothesis is H naught mu1 equal to mu2, means the means of the two populations are same. So there is no difference between the means of the two populations. See, in this case the variances are unknown, and therefore we need to find out the pooled variance in terms of their sample mean square. So what is the procedure in this case? See, first we have to take u1. So u1 is what? So that follows a normal distribution. We know that if X is a normal mu sigma square, then the value of X bar follows normal with mean mu and variance sigma square upon n. So therefore we suppose if you standardize this, that becomes our u1. So u1 is equal to X bar minus mu1 divided by sigma upon square root of n1, and u2 is X bar minus mu2 divided by sigma upon square root of n2. So why we are required this u1 and u2? Because we know that the test statistic t is based on the value of u and v. And what is this u? So u is nothing but, so u is nothing but my u1 minus u2, since I am interested in the difference between the two population means. What is my null hypothesis? My null hypothesis is mu1 equal to mu2. So this means mu1 minus mu2 equal to 0. So therefore we need to take the difference between the means. So therefore we are taking u as u1 minus u2. At the same time we have to take the values of v1 and v2. So V1 is what? So this follows chi-square with n1 minus 1, and this U2 follows, V2 follows chi-square with n2 minus 1. And what is my V1? Is summation xi minus x bar square divided by sigma square. V2 is summation yi minus y bar square divided by sigma square. So what is x? So x is my first sample, y is my second sample, and x bar is the mean of the first sample, and y bar is the mean of the second sample. Sigma square is the variance of the first sample, whereas the sigma square is the variance of the second sample. We are taking the sigma square and sigma square as same because our assumption is sigma 1 square equal to sigma 2 square equal to sigma square. So what is our u? U is u1 minus u2. So find out this value. We will be getting the difference between two normal population. So that means u1 follows again normal 0 1, u2 follows again normal 0 1. So the difference between u1 and u2 is also normal 0 1. And by using the additive property of chi-square distribution, what the additive property of chi-square distribution tells? Suppose if V1 follows chi-square with n1 degrees of freedom, V2 follows chi-square with n2 degrees of freedom, then V1 plus V2 follows chi-square with n1 plus n2 degrees of freedom. So since in this case we are taking n1 minus 1 and n2 minus 1 be the degrees of freedom, therefore what would be my V? V is nothing but V1 plus V2, that is summation xi minus x bar square plus summation yi minus y bar square divided by sigma square, and it follows a chi-square with n1 plus n2 minus 2 degrees of freedom. Now I know what is my t statistic. This is my t statistics, u divided by square root of v upon n1 plus n2 minus 2. So put all these values of u and v. So I am getting this equation, and from this equation I can reduce this value. So what is my ultimate t value? My ultimate t value in this case becomes x bar minus y bar minus mu1 minus mu2 divided by s into the s divided by square root of 1 upon n1 plus 1 upon n2, and this follows t with n1 plus n2 minus 2 degrees of freedom. And what is my s in this case? So s is nothing but the pooled standard deviation, and this pooled standard deviation we will be getting this as a sample mean. So the square root of sample mean square. So actually this is s square, and how to get the value of s square? This is summation xi minus x bar square plus yi minus y bar square divided by n1 plus n2 minus 2. So take the square root of this, so that will gives the value of s, and from this we can get the value of our t. Ultimate, the final, the test statistic becomes t is equal to x bar minus y bar divided by s divided by square root of 1 upon n1 plus 1 upon n2, which follows t with n1 plus n2 minus 2. So how this becomes? Because my null hypothesis is, so what is my null hypothesis? So mu1 equal to mu2, therefore mu1 minus mu2 now becomes 0. See, this is mu1 minus mu2, in this case now becomes 0. So the ultimate t statistic become t is equal to x bar minus y bar divided by s upon square root of 1 upon n1 plus 1 upon n2, and from this we will be getting the value of t n1 plus n2 minus 2. Find out the critical region. So what is the critical region in this case? The critical region becomes, so these are the critical regions. So what are the critical regions? So for this alternative hypothesis, since my alternative hypothesis is two-tailed, so my alternative hypothesis in this case is related with two-tailed. So therefore the value becomes, see, this is my alternative hypothesis for two-tailed test. This is my critical region for left-tailed test, and for right-tailed test. These are the three critical regions, and if calculated t is greater than table t, we need to reject the hypothesis, otherwise we have to accept the null hypothesis. So friends, this is all about the t test, unpaired t test, and that is also called as pooled or independent t test, in which our point of interest is we have to test the hypothesis that H0 is mu1 equal to mu2. Thank you very much.